why when I shine light at an angle into a triangular prism, does it break up into these different wavelengths, and when it comes out it breaks up or it disperses even more, and eventually to show the color spectrum when it is shone on a canvas or on some sort of light screen. Okay, so why does that happen? Well, the one thing that you need to understand is that when light travels in a vacuum, okay, so when light travels in a vacuum, then the speed of light is given by the constant c is equal to 3 times 10 to the power of 8. And we've already mentioned that, that's meters per second. However, when it is traveling through a medium, when it travels through a medium, in other words going through air or water, or in this case a glass prism, then there is what is called the index of refraction. Okay, the index of refraction. Okay, and the index of refraction is given by the formula n is equal to c divided by v. So what is this all about? Well, don't worry about it, it's not that important. All that you need to know is that velocity in the medium is less than the speed of light. So the speed of light is actually the very fastest possible speed in physics. You can't go faster than the speed of light. So when light passes through a medium, it goes at a lower velocity, and if we take the speed of light divided by the velocity of that wave in that medium, we get what is called the index of refraction. In other words, can almost be considered as a ratio by how much the speed of light is being reduced. Okay, in a sense, you can look at it like that. So that's the one thing that you need to understand. And the denser the medium, okay, so the denser the medium, so when density increases, the index of refraction increases. In other words, the velocity decreases. The velocity decreases. Okay, so why does this influence the refraction of light? Okay, so when light bends in a different medium, it's called refraction. Okay, and it bends towards the normal of the surface. Okay, so why is this true? Why does light refract? In other words, why does, first of all, why do the frequencies bend? And second of all, why do the higher frequencies, okay, the shorter wavelengths, bend more than the larger wavelengths? White light enters a denser medium when it hits at an angle. It is therefore refracted towards the normal of the surface, which would be somewhere there, okay, and then when it comes back out, it is refracted away from the normal. Okay, so there's the normal to the surface. Okay, it's refracted away from it. Okay, and therefore it looks like it's bending twice. There it bends a little bit off of its original path, which would have been there. Okay, it bends a little bit and then bends a little bit more off of its original path. It would have been there. It refracts twice, and that's why a triangular prism works better to not diffract it, to refract it twice. Now the next question is, well, why does it separate the different frequencies or wavelengths? Okay, well, think of it now this time like this. So we still have we're still using tires as our example. Imagine here we have a small tire and we have a larger tire, or wheels. Sorry, I shouldn't talk about tires, wheels. And they're approaching also a puddle, and they're going at the same velocity. Both of them are going at the velocity of the speed of light, let's say that, both of them are going at the speed of light, hitting that. Now, which one has a higher frequency? Okay, hopefully you know that the smaller tire will have, or smaller wheel will have a much higher frequency than the larger wheel, because if it has to keep up, one turn for this wheel displaces, let's say, a meter, while one turn of this only displaces 10 centimeters. So it has to turn much faster, so the frequency, the turns per second or per minute, is much higher. So when it hits the puddle of water, which one is affected more? Well, I hope it makes sense to you that the smaller one, the one with the higher frequency, is affected more than the one with the lower frequency. So if I look at this, which has the higher frequency of light? Well, let's go and have a look at our don't have it up here, I have it up here somewhere. Okay, let's go look for it. Okay, the longer the wavelength, the shorter the frequency. Okay, we see that from here. Frequency is equal to velocity divided by wavelength. So when wavelength increases, the numerator increases, the frequency decreases. So the longest wavelengths are the red, okay, which means they have the shortest frequency. The frequency for red is lower than the frequency for blue. So the red wavelengths, yes, they will bend, okay, but the red wavelengths will not bend as much as the blue wavelengths will bend. So if we have blue wavelengths, the blue wavelengths will bend more than the red wavelengths, and the other wavelengths in between will obviously bend in between there. So because the frequency for blue is higher, blue is almost like this small tire that is more affected by the change in velocity than the bigger tire.